NASA's renewed focus on the moon goes far beyond the excitement of landing astronauts on the lunar surface. This time, they're not only aiming to touch down and return, instead they have a long-term vision to establish a permanent, self-sustaining human presence on the moon that can support extended missions and pave the way for future exploration of Mars. Central to this mission is a highly specialized and often overlooked field, lunar logistics. While people are naturally drawn to images of astronauts planting flags or rovers exploring unknown terrain, few realize that the success of any sustained lunar program rests on developing sophisticated methods for delivering, handling, and moving massive quantities of cargo. NASA has acknowledged this challenge and is actively seeking solutions to transport supplies weighing anywhere from 2,000 to 6,000 kilograms, 4,400 to 13,000 pounds, across the moon's surface. With gravity just a fraction of Earth's, sharp temperature contrasts, and unpredictable terrain, the moon presents a unique set of obstacles to effective cargo mobility. Recently, NASA issued a request for proposals to the commercial sector, inviting private companies and innovators to contribute their expertise and propose solutions for this critical aspect of lunar infrastructure. This collaborative approach to lunar logistics is part of NASA's strategic vision. Rather than developing every piece of hardware in-house, they're tapping into the ingenuity and specialization of the private sector to fill specific gaps in lunar capabilities. The call for proposals underscores NASA's recognition that lunar exploration cannot be accomplished in isolation. It's no longer just about launching rockets. It's about designing a broad, interconnected system that can deliver and move life-sustaining resources reliably. By working closely with private companies, NASA aims to draw on a wealth of expertise and innovative ideas that can help bridge the gap between current capabilities and future needs. NASA's current plans for lunar exploration are structured around the Artemis program, a multi-phase initiative that aims to land astronauts on the moon within the next few years. While the Artemis missions are only the beginning, they represent the first step toward establishing a lasting lunar base. Key to this base is a logistics network capable of moving cargo over long distances in an environment that is more extreme and less predictable than anywhere on Earth. One of NASA's primary objectives is to establish a sustainable lunar outpost, which means ensuring astronauts have the resources they need to live, work, and explore the moon for extended periods. To make this possible, NASA must solve complex logistical challenges. In recent white papers, NASA has detailed the specific requirements and limitations they currently face. The first white paper, Lunar Logistics Drivers Needs, examines the critical role of accurate logistical forecasting. The authors argue that as the Artemis missions and long-term lunar goals are defined, it is vital to develop precise estimates of what astronauts will need to survive and work on the moon. This requires predicting how much food, water, air, scientific equipment, and spare parts will be required to maintain both human health and operational systems. Each Artemis mission will require a carefully calibrated mix of life-sustaining resources and specialized equipment to achieve scientific and exploration goals. But it's not enough just to deliver supplies to the moon. NASA needs a robust system for moving these supplies across the surface once they've landed. This is where the challenge becomes particularly difficult, as the moon's terrain is highly irregular, with a mixture of loose soil, rock fields, and steep slopes that make traditional cargo transport methods inadequate. Moreover, the moon's lack of atmosphere means there are no weather patterns, but that doesn't eliminate the risks of exposure. Temperatures on the moon vary dramatically between day and night, reaching highs of 127 degrees Celsius, 260 degrees Fahrenheit, in sunlight and dropping to minus 173 degrees Celsius, minus 280 degrees Fahrenheit at night. Any vehicle operating on the moon must be designed to function reliably in this extreme thermal environment. At present, NASA has several mobility assets in development, such as the Lunar Terrain Vehicle, LTV, and the Pressurized Rover. These vehicles are primarily intended for crew transport, allowing astronauts to travel around the lunar surface and perform various tasks without the constraints of foot travel. However, these vehicles have limited cargo capacity, maxing out at around 800 kilograms, 1,760 pounds, which falls far short of the 2,000 to 6,000 kilogram capacity NASA will eventually need. Moving heavy cargo is a different challenge altogether, and NASA is hoping that private companies will offer creative solutions to develop vehicles or systems that can handle much larger loads. In response to this need, NASA's call for proposals highlights a range of specific requirements. First, any proposed cargo system must be able to transport loads over considerable distances, potentially covering areas as diverse as the Moon's equatorial plains and the permanently shadowed craters of the South Pole. The South Pole is of particular interest because of its potential reserves of water ice, which could be used to produce oxygen and fuel. However, these regions also pose some of the greatest logistical challenges, with prolonged darkness, colder temperatures, and rugged landscapes that would test even the most advanced terrestrial vehicles. A reliable cargo system must be adaptable, capable of navigating through this unpredictable terrain while ensuring that cargo is delivered safely and on time. The second white paper, Lunar Surface Cargo, addresses the logistical issues of getting supplies from lunar orbit to the surface. Currently, most lunar landers are designed to carry limited payloads and have relatively small compartments for cargo. This is adequate for initial missions, but will soon prove insufficient for a more substantial lunar outpost. NASA envisions a fleet of landers with varied capabilities, each designed to transport different types of cargo to meet specific mission objectives. Some landers may need to carry specialized science equipment, while others might focus on delivering life support systems or construction materials for habitats. NASA is exploring the possibility of partnering with both international agencies and private companies to develop this diverse fleet of cargo landers, believing that a collaborative approach will help maximize the range and reliability of lunar resupply missions. NASA's strategy for lunar exploration goes beyond simply solving logistical problems. It's about creating an integrated system that can adapt to a wide range of mission requirements and future needs. The call for proposals includes a request for companies to offer assessments of integrated logistics solutions. This means that NASA isn't just looking for isolated ideas. They're interested in how different technologies might work together to create a seamless logistics network on the Moon. NASA's strategy also reflects a broader vision, a lunar logistics network that can evolve over time, adapting to the changing needs of lunar exploration and setting the stage for more ambitious missions to Mars and beyond. One of the most complex challenges in lunar logistics is the issue of energy. The Moon's lack of atmosphere and extreme temperature fluctuations create an environment where traditional power sources, like solar panels, face limitations. In the lunar night, which can last up to 14 Earth days, solar power becomes unavailable, leaving NASA to explore alternative energy sources, such as advanced batteries, nuclear power, or even thermal systems that can store heat during the day and release it at night. Any proposed cargo transport solution will need a reliable power source that can sustain operations for extended periods without frequent resupply. In particular, systems designed to transport heavy cargo will require large amounts of energy, making power management a critical component of any viable lunar logistics solution. NASA is keenly aware that a lunar logistics network could eventually lead to economic opportunities, as companies develop technologies that could serve both lunar missions and commercial applications. The agency's call for proposals encourages companies to think creatively and consider not only the immediate needs of the Artemis missions, but also the potential for a future lunar economy. This vision extends to the idea of resource utilization, where companies might one day mine and process lunar resources, such as water ice or lunar regolith, to support both lunar and Mars missions. NASA's ultimate goal is to create a lunar environment where logistics operate with a level of reliability and efficiency similar to supply chains on Earth. Achieving this will require collaboration across numerous fields, from engineering and robotics to energy and environmental science. By tapping into the expertise of private companies, NASA hopes to meet. As these collaborations take shape, NASA is not only preparing for the future of lunar exploration, but also creating a blueprint for sustainable space exploration on other planets. Through its call for innovative ideas, NASA is asking companies to join in on one of humanity's most ambitious endeavors. The vision of a moon with bustling activity, where supplies, equipment, and resources flow seamlessly across the surface, is closer than ever before. Every solution proposed will contribute to a vast logistical framework that will support astronauts and scientific missions on the Moon, and eventually serve as the launching pad for journeys to Mars and beyond. This strategic partnership with the private sector represents a historic turning point, one in which lunar logistics will transform from a series of small-scale missions to a large-scale operation that sustains life, supports science, and enables new frontiers. By laying the groundwork for this logistics network, NASA and its partners are creating the conditions for humanity's next great leap, a future where living and working on the Moon becomes a reality, and where the Moon serves as the gateway to the stars.